we're looking at mostly lines today, but there are some other equations. But we want to find out when you have two sets of lines or two sets of functions, when they have a solution together. Okay, so that's what we're looking at. Solving systems using tables, graphs, or CAS. And I'm going to cross out the CAS because actually you guys, your new calculators are not CAS. Okay, they're Inspire, and the Inspires can't do what the CASs did. Okay, so we'll still do it some with the Inspire, but it'll be a little different than these notes tell you. Okay, so a system is a set of conditions joined by the word and. The solution set of the system is the intersection of the solution sets of individual sentences in the system. You guys remember when I said intersection last week, it looked like, if I were to compare in two lines in this case, line A is intersected with line B. And what does that mean again? Point where they come together. What the point they have in common. So intersections are always the points they have in common. Okay? So we're looking for that point. And the way we're doing this today is actually graphing them and finding where they cross. Later in the week, we're going to be looking at solving it without graphing, but that's what we're focusing on today. So to solve a system, you can create a table or a graph. To speed up graphing, use equations in slope-intercept form, because then it's a lot easier to graph. Okay? So, if you look at this chart right here, you could see where these two lines cross right here in the middle. That's their intersection point. And I could say that is at month 5 and at a handicap level of 20. And I'm guessing this has something to do with golfing, but I'm not sure because I didn't read the story problem that's behind this. But that is the point that these two lines have in common. Okay? If you were to look at the table over here, you can see that they have 5 in common because they both have an output of 20 at that point. So wherever they are the same in the table, that's also your solution. So if you were solving by table, you would have to do a lot of guessing until you found the common point. Okay? Nice thing about graphing is you just graph it and you find it really quick. All right? So let's scroll on down here, and we're looking at systems. It says solve systems with a CAS. Well, we're not doing that. We're going to actually solve it by hand this time. So what I need you guys to do is somewhere on your page, if you have some place, is draw a Cartesian coordinate graph that looks like, yep, I know that sounded weird, this. That's Cartesian coordinate graph, okay? Well, you can do it, do it by 2s if you want. Just it should be between 1 and 10. North, south, east, and west, okay? So, we're going to graph the line of y equals 1/2 x minus 5. And we're going to graph the line y equals 2x minus 1. All right. When you're graphing these points, what is the very first point that you graph on the coordinate system? The y-intercept, okay? Very good. So I'm looking at this point right here, -5, and I'm also looking at -1, but we're going to do -5 first. So I'm going to go down 5. 1, 2, 3, 4, 5, and there's my first point. Okay, I'm going to use my slope to draw my next point. So my rise is what in my slope in this one? 1, and what's my run? 2. So I'm going to go up 1, over 2. There's my next point. Okay, and I can go from that point again. Up 1, over 2. up 1, over 2, and I can keep going. Okay, so there's my line, and if you draw it as straight as possible, and when you're doing this on your own, you might want to use a straight edge because you could really mess up where the intersection occurs if your line isn't straight. Okay. All right, I'm surprised that that line turned out as straight as it did, to be honest with you. It's not bad. All right, let's look at the next one. We're going to graph, first of all, again, the negative 1. I'm going to go down to negative 1 and put a dot. What's my slope on this one? Rise of 2, a run of 1. So I'm going to go up 2 over 1. Up 2 over 1. So on this one, I'm going to actually go down 2 over 1 as well because where they're going to actually intersect, I should say, is way back here. Okay, so this point right here is where they intersect. What is that point? It's over how far? Negative 3 and 7. Negative 7, right? So that is the point of intersection there. All right. Now, I want you guys to try this one on your own here. Y equals 3x plus 2. And y equals 2x minus 4. And see if you guys get the same intersection point I do. Oops. Okay, I don't know why it did that. Notice how it ran off the chart. Down here. Okay, so it is actually 1, 2, 3, 4 over. It's a negative 4. And down 11, I think, is what I have.
Won't it be going positive?
Mm-mm. Well, they're both going upward, right? The slopes are both of them are up.
Yeah.
So they're both going up, but where they intersect is back here.
Oh.
Yeah, you can check it. You can put them in. You can put negative 4 and negative 11 in both, and if you end up with the same point,
Yeah, I got way down there.
yeah. So if you check it, if you put negative 4 in for x, it'd be 3 times negative 4 plus 2. Okay, so that should be negative 12 plus 2. Maybe I guessed it wrong. So that'd be negative 10. So apparently I counted it wrong. See, this is why it's important to have a straight edge. Okay? This is what happens when you don't use a straight edge. So that's why when you guys are actually doing this on your test, make sure you have like a little ruler or something. Okay? You got negative 5 and negative 13? Yeah. It might have been. I have to double check again. The other way that you guys can do this, and we're going to talk about this later, is notice that the y's are equal here. I can set these two together. 3x plus 2 equals 2x minus 4. And solve for x. And that's how you can find your x value. So if you subtract 2x from both sides, I get x plus 2 equals negative 4. And then subtract 2, so I have x equals negative 6. So my x value should have been negative 6. And then plug that back in to find y. We're going to talk about that later in the week. Okay? All right, let's move on. Back to the notes. Kayla is a packaging engineer at Healthy Soup Company, and the marketing department has a request that she designs a new soup can. The volume must hold 360 mil. So I know V has to be 360 milliliters. Okay? Okay. And then it's a cylinder. And then it says, so that's important. An eye-catching new label must be large enough to show the product name and all the nutrition content data. and it wants the area of the label to be 225 centimeters. So when you're looking at a label, it's usually like a square area, right? So that area needs to be 225. Okay, so there's a couple things you guys got to think about when you're thinking about a cylinder. First of all, a cylinder, how do you find the volume of a cylinder? Pi r squared and times h, right? So pi r squared, which is the area of the circle. Yeah, but we're not doing that right now. So times h. Okay, so that's our volume for this. Oh, this one should be 360. I see what you're saying. Sorry, 360. Okay, so on this one, how do I find that label space? Where is it on the cylinder? It's on the front face, right? But notice that if you take a pair of scissors, think about this as a toilet paper tube. If you took a pair of scissors and cut the tube straight up and you lay it flat, what do you get? A rectangle, okay? So in this case, the circumference is our length. So that would be 2 pi r, right? What's our height in this case? It's just h again. Okay, so 225 equals 2 pi r times h. So what I want to do at this moment is I want to take and solve for h on both of these. Okay, and then we're going to graph those. So we have h is equal to 360 divided by pi r squared. And I'm going to, in a minute, going to change this to x and y so we can use our graphing calculator. Okay, on this one, h is going to be 225 divided by 2 pi r. So all we need to do now is we're going to actually use our calculator. I'm going to change h to f of x. And that's going to be 360 over pi x squared. And what do you think this one's going to be? I'm going to still say f of x again. This will be the second one though, right? This is the first one. 225 over what? Yep, 2 pi x. Right? So here's what we're going to do. You go to your calculator. Okay, I'm going to give you a minute to get out your calculators. You're going to open it up to the graphing function right there. Okay, so you're going to actually put in for f1 of x, you're going to put, and this one is 3 because I've already done this once before, 360 divided by 2, and then we also need the pi, and I can't see it on here because I can't see the, oh, there it is, 2 pi, and then I'm going to use x squared. So that's my first one. Hit enter. Oops, what did I do wrong? What did I do wrong, you guys? It's multiplying by pi x squared, so I need to fix that. Okay, so I need to put that back down on the bottom of this, okay? So once again, let's put pi on here. Okay, x, and then squared. There we go. Now, this makes a drastically different thing. Here we are. Okay? Now, the next thing I want to do is I need to graph my next function, so I'm going to put that in as 225 divided, and this time I'm going to use parentheses to make sure it stays on the bottom. 2 times pi times x. Okay, so question for you guys. Can you ever have negative numbers when you're looking at the sizes of something? So is it worth our while to even look on this side of the graph? How about down here? No. So what I want to do is I'm going to go to menu, and I'm going to go to zoom and change my window settings, because I'm going to tell it I want to start at 0, and I want to go up to, say, let's say 30. So this will change my window so that I will not have any negative values, and I'm going to go up to 30 on the Y as well. Look at there. Okay? I want to see where these two lines cross. Do you think it only crosses once or twice? It's probably going to cross twice. There's one that's off the screen, way over here, that we can't even see, and there's one that's on the screen right there. Okay? So one of the things I can do to find out where they cross is I'm going to go to Menu, Points and Lines, and look at that. Intersection points. So if I hit on intersection points, and then I'll tell it what I want it to measure. I'm going to measure graph 4 on mine. Yours is going to be like 2, and the other graph. If I put them together and look it gives me my point. Okay? So here's one of my points. This will give me my x value, which happens to be my radius, and my y value, which is the height of the cylinder. All right? And I can go out further and find out what my y value is, or my other point, which is way out here, which doesn't even seem like it's even a feasible number. Are we almost there? Did I pass it? Where is it? Okay, we know that the maximum, what's the maximum volume on this? 360. So x can't be 360. So anyway, it looks like that's the only possible answer that we have, was what we just had earlier. So I'm going to go back to view, I'm going to go to window zoom, and I'm going to say quadrant 1, there we go. And there's our point. So what you're going to write down for your answer is 1.6 is your radius, and 22.4 is your height. Okay? Let's go back to this now. Fred wants to enclose a 400 square meter rectangular garden. Okay, so we know that our garden, if I were to draw this picture, is 400 square meters. All right? And we only have 70 meters of fencing, so he's going to use one side, and I'm going to mark this as his barn, so he doesn't have to use that side for a fence, okay? We know that the length times the width is the area. So I could say 400 equals, I'm going to just change it to x and y, because that way we don't have to worry about changing it later. Okay? And we know that the 70 is the circumference, or the perimeter. Okay? So 70 is actually going to equal what in x and y? How many x's do I have? 2. So 2x plus y. All right. So on this one, we're going to actually solve for y and use the graphing calculator again. Okay. So on this first one, if I were to solve for y, I have y equals 400 divided by x. And that will be my first function. And on the second one, I'll have y equals 70 minus 2x. So I'm going to pause this for a minute, and I want you guys to try to put it on your calculator and see if you can get it to do it. And find the intersection point or points. There might be more than one, okay? So take a minute and see if you can do it. If you don't have a calculator, look at a neighbor's calculator, okay? This is what I got. Hopefully you guys got something like it. If you zoom into it, this is what you should see, okay? If you first graph it, it doesn't show up, you need to zoom in or zoom out, okay? So you're going to have to use that function on the window. And then when you add the green line, you notice that there is a point here, and if I use the intersection point thing, you get a point of 7.19 and 55.6. Okay? So one of my answers for this is going to be x, a value of 7, and a y of 56. That's one possibility. The other answer, if I go back to my graph, is 27.8 and 14.4. I'm just going to round it. So it's going to be 28 and 14 is my other possibility. Okay? So both of those should work for this. So when a system is nonlinear, it is possible to have more than one solution. All right? So if I give you this system right here, what would be my first step to solve it? What did I do up here first? Yep, so solve for y. Yep. Okay, that's the first step. And then you can put them into your calculator for these ones. So y equals 4x, it's already solved for y. For the second one, I need to solve that one for y. So 2y equals negative 6x plus 14. Do you guys see what I did? I subtracted 6x from both sides. And then I'm going to divide both sides by 2. So y equals, what's negative 6 divided by 2? Negative 3x. And what's 14 divided by 2? Okay, so I need to put this into my graphing calculator and this one as well. And guess what when you do that? Let's go do that real quick. I'm going to make a new document. Okay, so my first one is 4x. Well, if it lets me, 4x squared. So there's that one. Okay, and then my second one is going to be negative 3x plus 7, right? There's my other one. Okay, so I'm going to move this so I can see. It crosses in 2 points, doesn't it? So go to menu, points and lines, and then you go to intersection point. Okay, so I'm going to click on the green one and then click on the red one, and it gives me my 2 points right there. One of them is at 1 and 4, and the other one is at 1.7 and 12.2. Those are my 2 points of intersection. All right,